review, isn't it? So here's example 1. Solve the systems by graphing. And here are now 2 equations. You see? Usually we only had 1 equation and so forth. Now we have 2. So do you think graphing paper is going to really help you to do these? Especially if you're looking for, solutions? Yeah. You don't want to do it on a other paper. You want to do it on a graphing paper. Because you want to be accurate, don't you? Otherwise, you're not going to be accurate. So everybody go ahead and try. Oh yeah, it's example 1. Go ahead, try this now. So, how many people realize that the first equation has a slope of what? 1 and the y-intercept of? 0. What about the second one? Is this in slope-intercept form? No, because that's the form that we want to write when you're graphing it. So who could tell me how to rewrite this in slope-intercept form? Yes, Amber. Excellent. And as you can see, the slope of the first line is 1, the y-intercept is 0. Slope of the second line is -1, and the y-intercept of the second line is 6. So, how many people graphed it correctly? And what is this case 1, 2, or 3?
2. I mean 1.
Case 1 where the 2 lines intersect. Yes. Case 3 was when the 2 lines are parallel. Are they parallel? Do they have the same slope?
Yeah. Oh.
Yeah, 1 and -1 are different.
Yeah.
Okay, they're not the same. So, how many people think they have the right answer? Raise your
I
hand.
definitely have the right answer.
Okay, all right. How about, let me see. Who thinks? Jennifer, what did you get? What did you get as your solution? 3/3? 3, 3, yes, that's what I got. So, guys, notice something here. It's kind of different. So you have to graph these things. Since we're talking about systems, we're talking about 2 equations at the same time. You graph them in the same x and y axis, right? Same plane. And then, look at where they intersect. It is at 3, 3. So what is your solution? 3, 3. Yeah, that's your solution. That's where it's the solution is a order pair for this time, right? Because that's where the 2, right? Isn't 3, 3 a solution to the y minus -x plus 6 and the black one? Right? Aren't they the same solution for both of them at the same time? You see how? Yeah. So now, notice, why do you suppose I label these? You see how I label them? I didn't really label them when I was graphing one at a time. Did I? Why do you suppose I label these? Scott? Yeah, because when you're graphing systems, you're graphing more than one line. You have to let the readers know which one is which. Otherwise, it's kind of confusing. So, and how many people got 3, 3 as your solution? Okay, do you see, if you didn't, do you see why it's 3, 3 now? Okay, good. So write this down. This is really important. Okay. So the solution of system of equations in 2 variables is what? What does the solution look like? It's in what? Order pair. That are solution for both equations, or true, right? When you plug it in, right? Isn't it true for both equations? So I wrote down true, but really you could replace that with solutions. It's the order pair that are solution for both equations, okay? That's what we're saying the solution is, okay? So what do you think I have this? Why do I need this 2 variables? So solution of systems of 2 equations in 2 variables. What do I mean by 2 variables? Okay, this is what I mean. It's nothing hard. In one equation, if I'm using x and y, on another equation, could I use a and b as my variable? No. Okay, we gotta use the same variables. Yeah. Okay, so anyway, any question? And since we're using 2 variables, your solution is going to be an order pair, right? X comma y, right? So that's what I'm trying to say. Does this make sense? Okay, good. Let's review just for a second. Do you guys remember how to graph these inequalities? Remember, inequalities are like less than, greater than, easy. Less than or equal to. Okay, so who remembers how to graph x is less than 1 and x is less than or equal to 1 on a number line? Okay, raise your hand. What is the difference? So raise your hand. What is the difference between? So we're switching a gear a little bit because you see why we're doing this now. What is the difference between x less than 1 versus x less than or equal to 1 on a number line? Stephanie. First one has what? 1 solution? First one has, I could give you more than 1 solution. Yeah, first of all, how many solutions do these have? They have? Infinitely many. How many numbers do you know that are less than 1? A lot. Okay. Okay, what is the difference? Okay, then what is the difference between x less than 1 or x is less than or equal to 1? Tina?
So on the number line, the
x is less than 1 would be an open circle and it would go to the left.
Yes.
The arrow. And then x is less than or equal to 1 would be a closed circle and it would be going left.
That's right. It will look something like this. You guys remember from last time? So notice I have to have this circle, filled here, indicating that what? 1 is part of solution 2. X is what? Less than or what? Equal to 1. That's why there's equal to 1 part, right? But on the left, this one, x less than 1. Is 1 a solution to that equation? Very simple equation. Not equation, I'm sorry. Very simple inequality. Is 1 a solution to this one right here? No, it is not. Okay. That's why there is an open circle, indicating that 1 cannot be the solution. Any question? Do you guys remember this? Okay, why am I going over this? You'll see why in a minute. Okay.
Because
now,
it will be doing it.
kind of, yes. Very okay. So now what about this? Who knows how to solve for x? So second example here. Who remembers, let's see if you remember this rule. This is a very important rule about inequalities.
You switch
If I have negative x less than 1, let's actually look at this one first, okay? How do I get x by itself? And who knows how to solve for x? Kate? That's correct. You have to divide both sides by -1, and when you do, you must what? Reverse the inequality symbol. You guys remember that? Do we do this every time? Only when you're what? Who remember? Raise your hand. Only when you are, how about Kevin? Only when we divide by negative? That's not only case. Or multiply by negative. Very good. So, as you can see, the graph of this will look like this. How about this one? How would you do this one here? Negative x less than or equal to 1. This will be what? When you divide both sides by -1 or multiply by -1. Same thing, isn't it, this time? Don't you get x greater than or equal to -1? You must reverse it, right? And so here's the graph. So write this rule. You guys remember this rule? When you multiply or divide by negative, of course, when you have an inequality, and when you're solving, right? Rest of it is the same as as you're solving an equation. Everything's the same. Except when you multiply or divide by negative, you must reverse the inequality symbol. So you guys remember that fact? Okay? That's something that we learned before. So you need to know that.
It's like negative x is not equal to 1.
But we don't have that. Not equal to is not an inequality. That's not. Yeah. So that's very different. That's logic. Okay. So now, so I'm going to ask you to graph this one. Look at A. Everyone should know how to graph y equals to x plus 3, right? Okay. Can you all graph it on that graphing paper? Go ahead. Everyone try. You see why we're doing this right now. This is example 2A, okay? I'm hoping that everyone graph, whoops. Okay, hold on a second. Did you all get a graph that looks something like this, where the slope is 1, right? That's invisible 1, right? 1. The y-intercept is 3, so you go up 3, go up 1 to the right 1, remember? Now, what if I ask you this? Now, that's why we talked about inequalities just now, okay? What if I change the equal sign to less than or equal to? Go ahead, everybody try. Okay, good. Some of you remember, some of you don't. Okay, go ahead. Everybody try it. See if you know how to do this one. Go ahead, graph it. Here. So, let me ask you this question. Here, guys, listen. You look at example 2B. Do you think, raise your hand, how many people think that example 2A is included in example 2B? In other words, all the solution. Remember these points on this line. Everything's our solution. All these solutions, all these order pairs, do they belong to example B? How many people think that is true? That's right. Right. Why is A included in B? Why is the solution of A included in B? Yeah. It says it's less than or what? Equal to. That's correct. So if I'm just graphing, then the equal to part, wouldn't it be this line? Now how would you then represent everything that is less than?
Oh, I got this. You call me Miss
Molly.
Shade below it.
What do you think, Scott?
Shade above it.
You think you shade above? Anybody? So you guys remember, it's either
Shade either above or below.
it's either above or below. The question is, which one do we shade it below or above? That's the question.
That's my
How many people think below? Raise your hand.
I do.